Before we get going doing some Lewis dot structures, I want to make sure everybody knows where I'm getting the numbers of valence electrons. On the periodic table, when you look at this column, this is the noble gases. These all have 8 valence electrons. Next door, the halogens 7, 6, 5. Okay, and of course, we're doing covalent compounds, so we won't have these metals, but we will have hydrogen, and it has 1. Now we're ready to start doing some Lewis dot structures. The steps that you use are in the PowerPoint. It's very important that you follow the steps in order, especially when it comes to the electrons, when you actually are putting them on and when you decide to form a bond and a double bond or whatever. You can count the electrons first or after the first step. That doesn't matter as long as you do before you start putting them on. But anyway, so the first step is to draw a skeleton. And a skeleton means that you're just going to show them connected by single bonds. I'm going to put my atom that's different in the middle. So this has 3 atoms. That's what I mean. Oxygen is different, so it's in the middle. And then I've spread these out. It doesn't matter what sides I use. Kind of, for now, I'll try to stick to the 4 sides. But I could have drawn it like that as well. It'd be just as good. Okay, let's check how many valence electrons we have. If we look on the periodic table, we see hydrogen has 1 and oxygen is in the 6th column. So just adding these up, I have 6, and then 2 times 1, that's 2 more. So I have 8 valence electrons. Okay, when I start putting my valence electrons on, I'm always going to start with the outside atoms and make sure they have their octet first. And so one of the big keys, we need to know how to count these bonds. That dash represents 2 electrons. So right now, this hydrogen has 2 electrons, and hydrogen is happy with 2. So this hydrogen and this hydrogen already have enough electrons. So how many have I put on there already on this structure? I have 2 here and 2 there. So I've already put 4 on. I need to put on 4 more. Since I don't need them on my outside atoms, I will put them on my central atom, oxygen, my central atom, and I'll put them in pairs. Okay, so that's water. Let's try another one. We'll start by making our skeleton. Nitrogen is the different, so we'll put it in the middle. We'll put our hydrogens around on the sides. Doesn't matter which sides I choose. Now let's check with our number of electrons. Nitrogen has 5 and hydrogen has 1. So again, I have 8 valence electrons. How many are on the structure already? A dash is 2 electrons, so 2, 4, 6 electrons. I have 2 more. I check, always check the outside. Hydrogen doesn't need them. Hydrogen already has 2. So all the hydrogens are okay. So if I have extra after the outside, then I put them on the central atom in a pair. Okay, and one thing we didn't check on the last one that you should check is that after you get it drawn on there, make sure that each atom has an octet, or for hydrogen that it has 2. The hydrogens are pretty easy to see that they have 2, but when I'm counting electrons for nitrogen, I count all of those. So those electrons that are shared count for both atoms. So those 2 belong to hydrogen, and those 2 also belong to nitrogen. So this nitrogen has 2, 4, 6, 8. It has its octet. Okay, here's one that's kind of different because it doesn't have an obvious central atom. On some of these where we give you carbon compounds, organic compounds, carbon will be central. And so however many carbons you have, you just join those together. And then let's just distribute what's left, the two hydrogens, kind of evenly. So I'll put one on each side. That's kind of your best bet. We're going to do just a few really simple carbon compounds, so you'll know them. Okay, so we have our skeleton written. Carbon has 4 valence electrons and hydrogen has 1. So 8, 10, so there's 10 valence electrons. How many have I already written on here? I've written 2, 4, 6. So I've got 4 more to put on. Hydrogen doesn't need any. Hydrogen already has 2. So I'll put them on my carbons. And I have 4 to put on, so I'll put 2 on each one. Okay, and then that last step that we did on the last one is that we want to make sure everything has an octet. And if we check, let's just check one carbon. This carbon does not have an octet. It has a pair there, 2, 4, 6. It does not have an octet. So if that happens, then you need to move a lone pair in to make a double bond. And so what I mean is, if I take a lone pair here, I'm going to just X through them so I don't see them, and move them here. Now they're a bond. Then that can help the central one get its octet. And now you can see this carbon has 2, 4, 6, 8, so it has its octet. The problem is the other carbon does not. It still just has these 4 and these 2, so it only has 6. I'm going to go ahead and erase those. I suggest when you write in pencil that you kind of X those out and keep an X there, or make it really obvious if you erase them. When you start erasing electrons, it's really easy to get messed up and get the wrong number on there. But anyway, so this carbon only has 6. So the rule says I move a lone pair in. So I can move in this lone pair. I'm going to put it on that side to make another bond. And now you can see that each carbon, that carbon has 8. And this carbon has 8. So that's good. So we ended up having a triple bond. Let's do one more of these before we go back to our PowerPoint. This one's ozone, and so its skeleton is like so. Oxygen has 6 valence electrons, so this whole thing will have 18. When you put the electrons on, start with the outside atoms. So I'm going to start by putting electrons out here. These oxygens do need 8. Okay, and I added them until the outside atoms have enough. So each of the oxygens has 8 now, because this, remember, the bond counts as 2, 4, 6, 8. Okay, but I haven't put all my electrons on, have I? Because there's 8 and 8, that's 16. So I've got 2 more. If I have any left, I put them on the central atom. Okay, and then the last step, I check and make sure everything has an octet. And if you look carefully, the central atom does not. It only has 6 valence electrons, 2, 4, 6. So the rule says if we don't have enough, we'll move in a lone pair to make a double bond. And you know, if I move in this lone pair here, it won't do any good because I'll still have 6. So I'm going to have to move in a lone pair from one of these oxygens. And so I'm just going to choose this oxygen, like so. And you see now I have an octet for the central atom. If I look at all of these, I have 2, 4, 6, 8. This oxygen didn't lose any, it has enough. So everything has an octet. But you notice what I had to do. I had to choose which oxygen to move the lone pair in. When that happens, you need to draw the other choice. So let me show you what I mean. What if instead I had taken electrons from this end and made a double bond there? Okay. And the reason we do that is because when this happens, it really tells us something about the structure. It means that the structure actually has what's called resonance. What's really going on when you see that there's more than one place, and we're talking about equivalent places where the same elements involved, more than one equivalent place to put the double bond, it means that those two electrons are actually being shared by all three atoms. In other words, the true structure is going to have a single bond, but then, you know, that red line represents two electrons. Those two electrons are kind of being shared by all three atoms. So we call that delocalized electrons. Whenever you have it, you draw two possibilities for where the double bond could be, but keep in mind it's not really like we have the double bond here and now it's here, whatever. Those two electrons are really spread over. This is just how we kind of represent it, is to draw the possibilities. We draw arrows between, and these are called, this is two resonance structures. Okay, let's go back to our PowerPoint.